Okay, my friends, Roger once again, Mudfossil University, cutting right to the chase. This is the top of the Great Pyramid of Giza, Egypt. Well, guess what? The pyramids were not built from the bottom up. They were built from the top down. This was one big thing similar to Devil's Tower. Let me show you what this would have looked like when it was alive and a giant creature. All right, this is muscle fibers. This is from Science Photo Library, and this is literally tissue layers, and they come in these little tiny blocks just like the pyramids are made out of. And there will be blood supplies in here. One of them will be a vein, one of them will be an artery. Arteries empty out and they just make holes. Veins turn black. Alright, now this appears to me to be a restoration, trying to keep this from crumbling, this side. Now, if I'm right, I don't know, but this is how I would do it. I'd put in something like that to hold up that weight. Now, are they broke? It looks to me like they only come right down to here. All right, these are just wedges put in here to hold up the collapsing wall. These are all those little tiny blocks that I showed you before. And there's going to be holes running through here. There's going to be veins and arteries. Very few. Because when you're in this type of tissue, there's not a whole lot of nurturing to be done. I believe this is in the tendinous. I said muscle before. I'm not sure whether it's well, you know what? I'm going to show you something right now because I'm going to get into this today. I'm going to be on a show with a guy, the anatomist that I work with, and he's going to be talking about very similar things to this, only in a human body. Listen to this. You know, I was just getting ready to do this, and I'm feeling pretty confident about this. Has to be that muscle fiber I was showing you, and that this black is blood, and this was where the artery was, and these little holes are to feed these little muscle blocks. Now, I started to think to myself, well, there is some type of a possibility that this actually could be a tree, but I don't think so. They show them, well, I'm going to show you in a second. Chemistry could be done, and I think the chemistry was done, as I recall, and I was very confident that this was actually creature biology, and it has nothing to do with trees. But I could be wrong. Let me show you what they showed in the ancient maps. This is the kind of stuff needs to be totally investigated, but I'm quite certain that I'm on the right path with this. But that's what doing a deeper investigation is all about. I could be wrong. Okay, this is really good. This is how the pyramids were built in Egypt. This is Geopolymer Institute. Now, I'm just going to show you what they say, and they are trying to recreate how they're done, and they have a bunch of people, you know, pretending they're Egyptians, and, you know, they're making a production out of it, and this is what they're using. Let me come back a little further. Here they are. This is what they're using to make their blocks.
The limestone we used consists of fossil shells called new.
All right, you heard limestone, and now he's saying this stuff consists of fossil shells. Now listen to him very carefully.
Like those in the Giza bedrock.
Hold on a second. Let me back it up. This is ultra important you hear what he says, because he's going to talk about the kaolin clay. They're using seashells. And listen to what he says.
The limestone we used consists of fossil shells called nummulites, like those in the Giza bedrock. Like in Giza, our French limestone is so loosely bound it doesn't require crushing. But unlike in Giza, it contains no kaolin clay.
Unlike in Giza. So Giza has kaolin clay, which is skin. Okay, remember I talked about the kaolin clay? These are the different colors. These are the colors of skin because they were skin. They use them for slip clays to make really fine molds of clays. And they're also used in fine china. So when you're eating off fine china, well, that's what you're eating off of. Alright, now if you haven't seen this, you have to see this, well, you should see it first, best. It's called The Anatomy of Our Mother Earth, and I just put this up a little while ago, an hour or so ago. And this shows all about the kaolin clay and the structure of the earth and these gigantic what we just have no clue about how big these things are. Like that's skin. That is literally skin, the White Cliffs of Dover. Literally skin. And this is what skin is made out of, kaolin clays. And I show the kaolin clay again in here, and then I show my mud fossil here, and the muscle woven right into the mud fossil, and how they are made in the creature's bodies. And that's the bone right there. That's a tendon. That's the glue. That's the abrupt transition run right into the muscle, and the muscle fibers and the bundles. And I'm going to go through all this in the microscope, and then I show, I think, when it first came out of the ground a long time ago. Yeah, that's when it's still real bloody. That's the actual artery. Anyway, you should come up here, and I try to explain things as well as I can, and then we go from there. Now you see this? They're showing them built on top of tree stumps, they look like. They were built on top of creatures' feet. That's where they all stood over on this side, and they drowned and died all here. And then they just broke down the feet like they would at the Devil's Tower, very similar. Okay, it's not a tree because trees don't last in salt water. They actually tell you put salt water on your tree stumps so you can break them down and take them out real easy. They just don't last in salt water. So that, and I don't think those were tree stumps on the Giza Plateau. I think the people that saw them realized that they made them from the top down and thought they were trees. But I looked at the chemistry, and you did too. You heard them say kaolin clay is in the Giza Plateau ones. That's skin. That is not found inside of plant tissues and cellulose. Totally different. And also, well, there are blocks there, but those are muscle blocks, I believe. They are not related to tree stumps. I'd be very, very surprised if that was a tree stump. And in salt water, the whole earth was covered with a huge amount of very, very salty waters. They know about that. That's not a mystery. And the trees didn't make it. And salt water preserves flesh. And especially if it's a warm, hot saltwater flood, it would eat away at all of the wet, bloody flesh and turn it into mud, which is exactly what red clay mud is bloody flesh. And then you would have organs and everything separated out along those fascia planes because of salt preserves tissues. It doesn't do much for bones. And because it was so salty and there was so much chemistry, the invasion of the molecules, as I've been saying, is called nucleophilic substitution. They're always in this water for a long time. The waters eventually bring a molecule in that says, hey, me and you, we could hang together. We're not going to deteriorate, and as soon as we dry out, we'll just be a rock, and it's okay, let's do it. Well, done. And then this is exactly what happens. You end up with a stone, literally a stone. But it was at one time a bone. A bone, it's a stone. And that's all the bone that's left in this stone. Alright, so I think I would leave it alone.